I am Dr. Teresa Ferrara Bowens. I'm currently a principal investigator at the Institute of Chemical Defense. When you think about chemical warfare research, and that's primarily what I do in my lab, you may have heard in the news around April of this year that there was chemical bombings in Syria. And a lot of women and children were killed in those bombings. And they talk about a nerve agent called sarin. It's a German nerve agent, or a G-series warfare nerve agent. And I know I can't use I didn't realize this was going to be the platform here. I can't use my pointer. But what we do in our laboratory, you see the mouse that's up there, we expose small rodents to these nerve agents, and we see seizure activity occurring within 5 minutes of the exposure. Now, a lot of times, too, with these people that were exposed in Syria, they're also foaming at the mouth, and they're also experiencing these seizures. And what's actually happening is in your brain, you have transmitting neurons and receiving neurons, so you have constant nerve impulses that are occurring. And in the middle of the two, the transmitting neuron and the receiving neuron, what you're seeing is acetylcholine. And that is a chemical that's released by the transmitting neuron. It goes to the receiving neuron, and you have a nerve impulse. But what happens upon the nerve agent exposure is that there's a chemical also called acetylcholinesterase that's in that synaptic cleft, that space in the middle. And that agent takes over that cholinesterase. And when that happens, that acetylcholine, which are the green circles that are in the middle there, that chemical cannot be broken down. And when it can't be broken down, you have constant overstimulation of the receiving neuron, which is causing this overexcitation or these seizures that are occurring in our animals, as well as the people that are exposed to the different nerve agents. Now, in terms of inflammation, it's a little bit important for me to go through this pathway very quickly for you. IL-1 signaling is responsible for the inflammatory processes that occur in the body and in the brain. And we're looking at that inflammation after these agent exposures. So what you're seeing here in the green, right here, this IL-1R1 is a receptor. And IL-1 is a protein that binds to that receptor, and that causes this inflammatory response. However, there's a second protein, that IL-1RA in the red there, that will block that signaling from occurring. So what we do in our laboratory is we take mice and we actually use gene knockout mice, which means we knock out these genes. The IL-1R1 receptor is knocked out, and once it's knocked out, IL-1 cannot bind, and therefore you're not going to be getting this type of inflammation. However, we can also knock out that IL-1RA, and once that's knocked out, the IL-1 binds to its receptor, and you have this constant inflammation. Now, we look at the animals at 24 hours after exposure, and we also look at them at 18 days after exposure. And overall, I know you see charts up there, it's a little bit complicated, but what you need to know is that at 24 hours, the IL-1R1 knockout, so the one that's protected, they actually show protection at 24 hours from that neurodegeneration that's occurring. Unlike them, the IL-1RA knockout, RA, no way, the ones that are injured, are actually showing injury not only at 24 hours, but also at 18 days. So down here, what you're seeing with those green arrows, the piriform cortex, which is an area of the brain that is sensitive to seizure activity, is actually, there's holes in the brain tissue due to that nerve agent exposure. And that's a huge thing. The other area that we look at is also the amygdala, which is responsible for your fear response. So those two brain regions are affected by that nerve agent exposure. So what you're seeing down here, these are microbeads for one of the kits that we use, and you can think of them as having primary antibodies or sticky substances that take all of this IL-1, so this inflammatory protein that's occurring after the exposure, and it's sticking to these beads, and then we can quantify how much of that IL-1 is seen in our animals. And what we see here in these top charts, again, not that complicated. The green line is the IL-1RA knockout. Those animals have a high accumulation of that IL-1 protein. So we're seeing more damage in these animals. We also look at behavior, and you see these two mazes here at the bottom right. The first one is called a zero maze, and what we measure, we put the animal in the closed quadrant area there of the maze, and we measure the time it takes for the animal to actually leave that quadrant. And most of our exposed animals, including the IL-1RA knockouts, since they're more injured, they're taking a lot more time to leave that area, which means, again, in terms of anxiety, because that test measures anxiety, those animals are considered to be a lot more anxious after the agent exposure.